Right now, at this exact moment, North Korean military officers are landing in Tehran carrying technical blueprints for hypersonic glide vehicles and mobile missile launch systems. The Pentagon claims these advisors pose no immediate threat to regional stability. Iran's supreme leader just posted on X, "Our friends from Pyongyang bring knowledge the West cannot stop." One of them is lying, and the next 72 hours will reveal whether the most sanctioned regimes on Earth just formed the most dangerous military partnership in modern history. Let me walk you through exactly what happened. On Tuesday, March 18, 2026, at 0342 hours local time, a chartered Mahan Air Airbus A340 departed Pyongyang's Sunan International Airport with its transponder turned off. Commercial flight tracking networks lost the aircraft over Chinese airspace near the city of Urumqi at approximately 0920 hours. 15 hours later, on Wednesday, March 19th, at 0230 hours Tehran time, that same aircraft appeared on approach radar to Mehrabad International Airport, Iran's primary military civil aviation hub located 8 kilometers west of downtown Tehran. Iranian Revolutionary Guard Corps ground units secured the tarmac before the aircraft landed. No customs inspection occurred. No passenger manifest was filed with Iranian civil aviation authorities. According to 3 Western intelligence officials speaking on condition of anonymity, satellite imagery captured by commercial provider Maxar Technologies shows a convoy of 7 black SUVs departing the airport at 0347 hours, traveling directly to a secure Revolutionary Guard facility in northern Tehran known as the Imam Hossein University Compound, a known research center for ballistic missile development and advanced weapons systems integration. The convoy arrived at 0423 hours. As of this recording, those vehicles remain parked inside the compound. The occupants have not emerged. Who exactly arrived on that flight? Multiple intelligence assessments suggest a delegation of 12 to 15 North Korean military personnel led by Jang Chang-ha, director of the Academy of Defense Science, North Korea's primary weapons development organization responsible for the Hwasong-17 intercontinental ballistic missile and the recent Hwasong-19 solid-fuel ICBM tested in February 2025. Jang Chang-ha is not a mid-level bureaucrat. He is Kim Jong-un's personal weapons architect, the man responsible for transforming North Korea from a nuclear aspirant into a credible thermonuclear power with intercontinental delivery capability. His presence in Tehran signals technology transfer at the highest strategic level. Accompanying Jang, according to South Korean intelligence sources cited by Yonhap News Agency and confirmed independently by Japanese defense officials, are senior engineers from the Sonam-dong Missile Research and Development Facility and technical specialists from Factory 395, North Korea's primary solid rocket motor production plant. These are not symbolic advisors. These are the engineers who built the missiles that can reach Los Angeles. What are they bringing? According to a classified intelligence briefing leaked to the Washington Post and confirmed by European defense sources, the North Korean delegation carried encrypted digital archives containing complete technical documentation for solid-fuel ballistic missile production, hypersonic glide vehicle aerodynamic designs, mobile transporter erector launcher engineering specifications, and potentially miniaturized nuclear warhead integration protocols. Iran has struggled for 2 decades to develop reliable solid-fuel missile technology, the critical innovation separating slow liquid-fueled systems requiring hours of preparation from rapid-response solid-fuel missiles that launch within minutes of deployment. North Korea mastered solid-fuel technology between 2017 and 2024, conducting 17 successful tests of the Pukguksong series and the Hwasong-18 solid-fuel ICBM. If North Korea transfers this capability to Iran, the strategic balance across the Middle East fundamentally transforms overnight. Every American base from Qatar to Bahrain to the United Arab Emirates currently relies on early warning systems detecting Iranian missile preparation activities hours before launch. Solid-fuel missiles eliminate that warning window entirely. To understand the significance, you need to understand what North Korea has actually achieved. The Hwasong-18 is not a modified Scud derivative or an improved Shahab. This is a 3-stage solid-fuel intercontinental ballistic missile with demonstrated range exceeding 13,000 kilometers, sufficient to strike any target in the continental United States from North Korean territory. The missile measures approximately 25 meters in length with a diameter of approximately 2.4 meters. It launches from an 11-axle transporter erector launcher, the largest mobile missile platform ever constructed, manufactured at the February 11 factory in Jiagang province using domestically produced specialized steel alloys and Chinese imported hydraulic systems. The missile employs thrust vector control for precision guidance, composite materials in the airframe for weight reduction, and cold launch technology ejecting the missile from its canister using compressed gas before main engine ignition, protecting the mobile launcher from exhaust damage, and enabling immediate relocation after firing. North Korea tested this system successfully in April 2023, July 2023, and December 2023, demonstrating operational reliability across different seasons and weather conditions. This is not experimental technology. This is production-ready, combat-deployable capability proven through repeated testing. Now consider what Iran currently fields. Iran's most advanced ballistic missile, the Khorramshahr-4, represents significant improvement over earlier systems but remains liquid-fueled, requiring fueling operations taking 1 to 3 hours depending on environmental conditions and crew readiness. The missile achieves range of approximately 2,000 kilometers with a payload of 1,800 kilograms, sufficient to strike Israel, Saudi Arabia, or American bases across the Persian Gulf, but the fueling requirement creates vulnerability. American surveillance satellites equipped with infrared sensors detect fueling operations. Reconnaissance aircraft monitor Iranian missile sites continuously. Israeli intelligence maintains human sources tracking Iranian Revolutionary Guard Corps' aerospace force activities. This multi-layer monitoring system provides warning time measured in hours, allowing preemptive strikes destroying missiles before launch or enabling defensive preparations reducing attack effectiveness. Solid-fuel missiles eliminate every layer of this warning architecture. A truck carrying a solid-fuel missile drives from underground storage to any location in Iran, stops, raises the canister, and fires within 8 to 15 minutes. No fueling, no preparation, no warning. Strategic significance extends beyond launch speed. Solid-fuel missiles enable distributed operations impossible with liquid systems. Iran currently concentrates missile forces at approximately 25 fixed sites across the country because liquid fuel systems require specialized infrastructure including fuel storage, oxidizer handling, climate-controlled preparation facilities, and security perimeters, protecting vulnerable fueling operations. American and Israeli military planners know every site location. Strike packages exist for neutralizing Iranian missile forces through coordinated attacks on known facilities. Solid fuel technology destroys this targeting paradigm entirely. Iran could disperse hundreds of mobile launchers across its 1.6 million square kilometer territory, moving continuously, hiding in commercial traffic, storing in civilian warehouses, deploying from anywhere. The targeting problem becomes mathematically unsolvable. You cannot preemptively strike what you cannot locate, and you cannot locate missiles that look identical to commercial trucks until 8 minutes before they fire. But the technology transfer potentially extends beyond solid fuel propulsion. According to Dr. Jeffrey Lewis, director of the East Asia Non-Proliferation Program at the Middlebury Institute of International Studies, who analyzed North Korean missile developments for 2 decades, the recent Hwasong-19 test in February 2025 demonstrated maneuvering re-entry vehicle technology, meaning the warhead can adjust its trajectory during descent, complicating interception by missile defense systems designed to intercept ballistic targets following predictable parabolic paths. If North Korea shares this technology with Iran, the effectiveness of Israel's Arrow 3 missile defense system and America's THAAD batteries deployed across the Gulf degrades significantly. Current interception algorithms assume warheads follow ballistic trajectories determined by launch parameters. Maneuvering warheads invalidate these assumptions, requiring entirely new intercept strategies and potentially rendering existing defensive architectures obsolete. Here's the calculation from Tehran's perspective. Iran faces military pressure from 3 directions simultaneously. Israel possesses nuclear weapons and precision strike capability threatening Iranian nuclear facilities, leadership compounds, and critical infrastructure. The United States maintains carrier strike groups, stealth bomber wings, and forward-deployed forces capable of devastating conventional assault. Saudi Arabia and the United Arab Emirates field advanced air defense networks and precision-guided munitions purchased from America and Europe. Iran's response has always been asymmetric warfare, ballistic missiles, drone swarms, proxy forces, and strategic depth, but American technological superiority and Israeli intelligence penetration have limited missile effectiveness. The Supreme Leader and the Revolutionary Guard command structure understand that conventional military confrontation with America or Israel ends in Iranian defeat. Their strategy requires deterrence through demonstrated capability to impose unacceptable costs, specifically the ability to strike American bases, close the Strait of Hormuz, and overwhelm Israeli missile defenses with saturation attacks. North Korean solid fuel technology transforms this deterrence calculation from theoretical to operational. Iran gains the ability to threaten credible retaliation even after absorbing American first strike, fundamentally changing escalation dynamics across every potential confrontation scenario. From North Korea's perspective, this technology transfer makes perfect strategic sense despite apparent economic irrationality. Pyongyang has invested 4 decades developing nuclear weapons and ballistic missile technology at enormous cost, enduring international sanctions, economic isolation, and periodic famine. That investment produced strategic autonomy. No nation threatens North Korean regime survival because regime change war risks nuclear retaliation against Seoul, Tokyo, or American forces in the Pacific. Kim Jong-un now possesses excess capacity, proven missile technology exceeding immediate deterrence requirements. Converting that excess capacity into strategic leverage through technology sales generates multiple benefits. First, financial return, alleviating sanctions pressure through hard currency payments or resource barter arrangements. Second, geopolitical leverage, complicating American strategic priorities by forcing Washington to address Iranian capabilities enhanced by North Korean technology. Third, ideological solidarity with fellow sanctioned regime, creating common cause against American hegemony. Fourth, practical testing ground for North Korean weapons systems in potential real-world conflict scenario without direct North Korean involvement. According to Ambassador Robert Gallucci, former chief U.S. negotiator with North Korea during the 1990s nuclear crisis and currently distinguished professor at Georgetown University School of Foreign Service, North Korea has historically provided ballistic missile technology to multiple Middle Eastern states, including Iran, Syria, Libya, and Egypt, generating revenue while spreading military capabilities that complicate American military dominance in strategically critical regions. The current transfer represents escalation in scope and sophistication, but follows established pattern of North Korean proliferation behavior dating to the 1980s. What makes this transfer unprecedented is timing and capability level. Previous transfers involved Scud derivatives and Nodong missiles, 1960s-era Soviet technology that North Korea reverse-engineered and exported. The current transfer involves cutting-edge solid fuel systems representing North Korea's most advanced operational capability, technology Pyongyang only achieved operational status with in the past 3 years. This suggests either dramatically increased North Korean willingness to proliferate advanced systems or equally dramatic Iranian payments, making the transfer economically compelling despite strategic risks. What payment could justify this transfer? Iranian oil reserves exceed 157 billion barrels, 4th largest proven reserves globally, but international sanctions severely restrict export capacity and revenue generation. North Korea requires reliable energy supplies for industrial base and military operations. A barter arrangement exchanging missile technology for sanctions-resistant oil shipments would benefit both parties while circumventing dollar-dominated international financial systems. Alternatively, Iran could provide access to uranium ore from the Sagand mine in Yazd province, supporting North Korean nuclear weapons program expansion. Or Iran could offer intelligence sharing on American military operations, capabilities, and tactics gained through decades of confrontation with U.S. forces across the Middle East, providing North Korea with targeting data and operational insights valuable for Korean Peninsula contingency planning. There are 3 possible scenarios. Scenario 1. Diplomatic intervention prevents technology transfer completion. Probability assessment, 25 to 30%. For this scenario to materialize, the United States and regional allies would need to impose immediate severe costs on both Iran and North Korea, potentially including expanded sanctions targeting specific individuals involved in the transfer, cyber operations, disrupting technical documentation, or covert action eliminating key personnel. International pressure through the United Nations Security Council could theoretically constrain the partnership, but China and Russia possess veto power and have historically protected both North Korea and Iran from severe international consequences. This scenario requires either unprecedented Chinese willingness to pressure Pyongyang over proliferation concerns or successful covert operations preventing documentation transfer. Neither appears likely given current geopolitical alignments. China views North Korea as strategic buffer and will not fundamentally undermine regime stability over arms sales to Iran. Russia actively seeks to complicate American strategic position and would potentially support technology transfer, weakening American Middle East posture. Scenario 2. Limited technology transfer occurs, but operational implementation requires years. Probability assessment, 45 to 50%. This represents the most likely trajectory. North Korea provides technical documentation and expert consultation, but Iran faces significant challenges translating blueprints into functioning production capability. Solid fuel rocket motor manufacturing requires specialized materials including ammonium perchlorate oxidizer, aluminum powder fuel, and hydroxyl-terminated polybutadiene binder. Iran possesses chemical industry capacity to produce these materials, but achieving consistent quality control and proper mixing ratios requires extensive trial and error testing. North Korea needed 17 tests across 6 years to achieve reliable Hwasong-18 performance. Iran would require similar testing program, meaning first operational solid-fuel Iranian missiles appear between 2028 and 2030, creating 3 to 4 year window for diplomatic or military intervention before capability becomes operational reality. During this window, American and Israeli intelligence will monitor Iranian testing activities. Each test provides targeting opportunity and intelligence collection, revealing system capabilities and limitations. If testing occurs inside Iran, Israel may conduct preemptive strikes destroying facilities before production begins, similar to Operation Orchard destroying the Syrian nuclear reactor in 2007. Scenario 3. Rapid technology transfer creates operational Iranian solid fuel missiles within 12 to 18 months. Probability assessment, 20 to 25%. This nightmare scenario assumes North Korea provides not just documentation but actual hardware, either complete missiles for reverse engineering or critical components Iran cannot manufacture domestically, including guidance systems, thrust vector control mechanisms, and composite materials for airframe construction. If hardware transfer occurs, Iran could potentially deploy limited numbers of North Korean-built missiles modified for Iranian requirements while simultaneously establishing domestic production infrastructure. This compressed timeline would catch American and Israeli defense establishments unprepared, potentially triggering preemptive military action before capabilities become operational. The risk of preventive war spikes dramatically if intelligence assessments conclude Iran will field solid fuel missiles within 12 months, creating use-it-or-lose-it pressure for strikes against Iranian missile facilities and potentially against North Korean advisors still in Tehran. Watch for 5 critical indicators in the next 48 to 72 hours revealing which scenario is materializing. First, satellite imagery of the Imam Hossein University compound. If North Korean advisors remain inside for extended periods suggesting technical consultation rather than brief diplomatic visit, technology transfer is actively occurring. If they depart within 48 hours, this may represent symbolic cooperation without substantive technical exchange. Second, Iranian state media coverage. If Tehran publicly acknowledges the visit and describes it as strategic partnership for defensive systems, they are signaling technology transfer to international audiences and domestic constituencies. If media remains silent, Iran may be attempting to keep transfer covert until capabilities are demonstrated. Third, American diplomatic response. If the State Department issues stern warnings but takes no concrete action, Washington may assess the threat as manageable. If sanctions are immediately expanded or military posture changes in the region, intelligence assessments conclude the threat requires urgent response. Fourth, Israeli military movements. If Israeli Air Force increases readiness levels or conducts unusual training exercises, their intelligence services may possess information suggesting imminent threat requiring preparation for preventive strikes. Fifth, North Korean follow-up visits. If additional flights from Pyongyang arrive in Tehran within 2 weeks, this suggests ongoing technical consultation requiring multiple expert teams, indicating serious long-term cooperation rather than one-time engagement. The talks just ended, or they haven't started, or they're happening secretly. We don't know. That uncertainty either means covert diplomacy is working quietly or both sides have abandoned restraint entirely. Either way, the next 72 hours determine whether we're witnessing defensive cooperation between sanctioned states or the birth of a ballistic missile partnership that fundamentally reshapes deterrence calculations from Tel Aviv to Riyadh to Seoul. I'm tracking this minute by minute. I have sources monitoring diplomatic channels, satellite imagery providers, and defense intelligence networks across 3 continents. When the next development breaks, when those advisors leave Tehran or when testing begins or when strikes occur, you'll understand it here first before any mainstream outlet explains what it actually means. Subscribe to this channel right now. Turn on all notifications. You need to know what happens next, and you won't get this level of technical analysis and strategic assessment anywhere else. Hit that subscribe button. Drop a comment. Do you think Iran can actually operationalize North Korean solid fuel technology within 18 months? Do you think Israel will conduct preemptive strikes before testing begins? Do you think China will constrain North Korea or quietly support proliferation that complicates American strategic priorities? I read every comment and I want to know what you're seeing that I might have missed. Thanks for watching. The advisors just landed. The blueprints are in Tehran. The clock is ticking. The next 72 hours will determine whether this becomes the most dangerous military partnership since the Soviet Union armed Cuba with nuclear missiles in 1962.